Good afternoon,
Hi,
everybody.
good morning, good afternoon, whatever. Okay, so hello everyone. Thank you for inviting me to speak in this panel today. My name is Amir Cohen, and I'm the founder and CEO of EGM. EGM is an American-based company with headquarters in Florida and the R&D center in Israel. We mainly sell in US and Europe. EGM provides a solution for grid operation and management. Our system includes strong analytics with AI and machine learning, which produces useful insight for the operation and management of both transmission and distribution grids. In order for the analytics to generate comprehensive, useful insight, the system also monitors the grid using a small number, I would like to emphasize, very small number of very advanced sensors. The theme of this panel on the future of the UK transmission network is closely linked to the overall object of understanding present and future challenges faced by the grid in the UK. I would like to do today is the focus on the challenge I deem most critical, which is the incorporation of renewable energy sources into the grid, and then present some technologies that we have developed precisely for the purpose of answering these challenges. The general starting point is that the world strives for net zero, and to get there, we need more clean electricity that comes from renewable resources rather than fossil fuels. I feel that you will agree with me that if 20, 25 years ago, governments had to subsidize project developers who installed solar panels, but today there are many areas in the world that where solar electricity is sold for 2.5 cents per kilowatt hour, which is the lowest available price. So on its face, we have actually reached the target of clean and cheap electricity. In light of this development, an interesting equation with two vectors was created. One vector is project developer and others who are eager to invest in solar and wind generation facilities because they have clear business model. A solar farm project developer knows what his expected income will be throughout the life cycle of the project. The second vector is us, the consumers. We naturally prefer the use of clean energy, and we can also include larger stakeholders such as government and regulators who can quantify the benefits created by renewable energies as a result of the effort to reduce global warming and the improvement of health as a result of better and clean air. But there is always a but. Someone forgot that in this equation, there are three vectors and not just two. And the third vector is the grid. The grid does not cause net zero, but without it, our expectation will not be fulfilled. The problem was that unlike project developers or government, a utility that operates the grid did not have a clear business model when it come to renewable energies. If it was only a matter of adding electricity using a traditional method intended to meet the increase of demand and not for replacing fossils, a few more power lines or even replacing wires and pylons would be enough. Then the payment, the utility charger for the infrastructure and operation would be enough. However, we are dealing with completely different generational domain, which is based on huge number of distributed resources. Let's see an example. I would like to use a use case of a utility of 6 60,000 kilometers of transmission line and 60,000 kilometers of distribution network, sells 70 billion kilowatt hour annually for approximately 3.1 million customers. 15 years ago, it was fed by, again, 15 power plants, large power plants. Today, this utility is fed by 26,000 renewable resources, small, medium, and large, which provide about 12% of the consumption. And since the goal for the year 2030 is 30% renewable energies, it is expected that those 26,000 resources will almost double to reach about 50,000. Additionally, renewable resources are unstable. Their power generation changes all the time due to light level or wind speed. Such rapid fluctuation in power negatively affect the voltage in the network and they endanger the power quality. The harmonics created by the inverters have a negative effect on the transformers. Also, the price change daily and even during the day, obliging the utilities to change the flow direction in accordance with the optimization of price. Meeting these requirements require a super high level of adaptability and flexibility of the grid. And I'm talking about transmission, which requires digitizing the grid with advanced control system, and that has a high price tag attached to it, much higher than adding few more power lines. In such situation, if the utility does not see how it returns its investment, how do we expect them to invest? The answer to this issue is very simple. If electricity from renewable resources produce such large benefits, it is possible to allocate a very small percentage of these benefits to the utility, which will be able to finance the upgrade. And by very small percentage, I'm talking about only few tenths of a penny per kilowatt hour. So just a quick recap before I move on, what we see is that after years of delay in grid upgrading, the momentum created by introduction of renewable energy and other reasons such as extreme weather was so strong that it managed to break conservatism and start the transition of the electricity grid itself. How do translate this momentum into action? This is where EGM come into play, and I will now quickly demonstrate the technological capabilities that allow the transmission and distribution network to meet the challenges. Our Meta Alert system is a comprehensive operation and management solution for the entire grid. In addition to transmission, also distribution, and for overhead and underground grids. The system creates and provides a wide set of useful information for the operation and management of the grid by continuously collecting real-time big data from the grid by very few advanced sensors scattered in some places on the grid and processing a wide range of unique grid insight produced and processed by advanced AI and machine learning driven analytics. The system provides many benefits, and to name just few. Full grid visualization on GIS and schematic presentation, power line load planner simulator, enable line loading planning for maximizing asset utilization, accurate fault location detection. One set of sensors at the beginning of a circuit will give us an exact fault location, even the circuit is 100-mile long. Momentary fault detection is very important to prevent power outage because their nature, momentarily fault, turn over time into a continuous fault. And grid topology tracker is important in the area of frequent change of the flow direction. Also, the system provides PMU, phasor measurement unit, a wire movement like galloping, etc. And of course, the system capable to interface with any other systems like TMS, etc. I would like a few words about dynamic line rating. Dynamic line rating is considered as a critical factor in maximizing asset utilization by defining the maximum allowable current and capacity in the conductor at any given moment without exceeding the temperature limits for the conductor. Thus, when we think about future grid, we expect DLR to do the following: real-time DLR, short-term DLR prediction using ambient adjusted rating, time to exceed maximum temperature, maximum wire temperature, I mean, a line load planning simulator for very long time, etc. A cable sag in some sensitive location above highways, etc. Cable tension and the long-term prediction. In conclusion, when we think about the future of the UK's transmission network, we need to realize its paramount role in the overreaching goals of reaching net zero through clean electricity. The massive resources devoted to creating accessible and affordable renewable energy resources have created a bottleneck at the grid level, and now we need to direct our attention to strengthening the grid itself, and do that in a way that is not burdening the utilities.
Yeah, just to introduce myself, I'm Phil Thompson. I'm the CEO of Balance Power. We're a renewable and flexible energy developer. So as Amir rightly said, we are at the part of the value chain where we are creating the renewable and flexible energy projects that will generate the electricity that goes into the grid. I think Amir will agree with me. The grid challenges that we're facing today probably could have been foreseen quite a long time ago when the net zero targets were first set. No one appeared to put their hand up and say, if we're going to operate a net zero system, we actually have to have a grid infrastructure that is capable of running that system. So we're aware of the problems now, and I think it's about the solutions that we now implement to get there. So as Amir puts it, we need to get more out of the existing system as it is. How do we sweat that as hard as possible? And then the next part is how do we build the new part of the system? So I think it is on there is a planning component to that if we are going to achieve this goal quickly, there needs to be a fast track approach to build the miles and miles of new pylons and cables. As we know in the UK, we don't do planning for big infrastructure projects very quickly. So we've really got to get a move on doing that. The big then challenge for me is obviously there is us in the developer phase, building the new projects. There is then the grid network, which takes that power to consumers and businesses. But then the next part of it is, well, what are the consumers and businesses doing to make this transition easier? So developers can play their part, the grid has to do their part, but what can consumers do? And I think more needs to be done on the consumer, and particularly the big commercial industrial energy users, for them to know what the solutions are, for them to be able to reduce the strain on the grid and also decarbonize what they're doing. So there is pointless for us as energy developers trying to push more energy onto the system for large commercial industrial users to be taking that power out on the other side. What we need to do is how can those large energy users almost self-consume that power in real time? And also what can the DNOs and National Grid do to allow that to happen? That will allow more projects to be built. It will allow businesses to cut their costs and decarbonize, and we'll all reach the collective goal much quicker. So those are the challenges for us. Is how do we get more out of the existing system? How do we build once we've done that, which is the quick wins and the easy stuff to do? Then it's how do we get the more complex bit, which is going to be needed to get to that eventual net zero goal. The last part is without using this really restrictive piece of infrastructure we call the grid, how do we get businesses to, particularly the large energy users and homes, to almost not put the pressure on the system? How do we think a little bit beyond the confines of the grid infrastructure? So Amir, I don't know what what your thoughts in particular are on the solutions there that are able to sort of enable consumers to be able to consume their energy more in real time. There is software available, but the implementation of it seems to be very slow and not very well understood. So whether that's a communications point or an understanding point, what are the barriers you see to be able to get consumers really connected up faster?
I think that the complexity of the problem, of the challenges, requires high level of integration between several components might be solve the problem. And we found when we developed our comprehensive solution, we came from a very a lot of experience that the interface is quite big issue. And that's why we thought about quite comprehensive system to prevent part of the integration and interface. Interface, sometimes it's endless project. So first of all, it's question of integration between variety of capabilities. And second, and if I also relate to a question came from one of the audience, the regulators should understand the effort required and the budgets required in order to solve the problem, and then to enable do that. And I believe that the regulators should allow more and more flexibility of a variety of models, renewable energy models, etc. So to be more concrete, there are solutions to deal with, to manage the grid in a way that will prevent and deal with problems like power quality, like voltage fluctuation due to power drop down while a sky covered by black clouds, etc. There are solutions. Even we have several. So I think utilities should be more open for a variety of potential solutions and allocate part of their grids in order to run several pilots in parallel in order to see what is the best one. Just 2 months ago, we have been in Europe in a very interesting experiment that a group of utilities tested variety of options or possibilities how to deal with variety of challenges. And it was amazing how much insight had been created and accumulated by these transmissions utilities. So again, integration and being open, not so conservatives, will lead the change we are all looking for.
I think that's it, isn't it? The solutions are out there, and both the DNOs, grid, the developers, they know the solutions are there. And in our experience on speaking to grid engineers, they're like, yeah, we know that solution works, and what you're proposing is right, but that's not really hardwired into what we're allowed to do. So although it's technically correct, we're not allowed to do that because no one's updated our policies to allow us to do it. And the question is to me is, well, can you go and update your policies, and can you update your rule book for the modern world? And nobody seems willing to sort of go from a DNO and a grid side and say that's a really good idea. It's actually technically safe and within the parameters of what we're allowed to do. We'll go and make a home for that. We'll find a way of making this work. And I think it's having the more flexibility there to be able to push solutions through, and with technology advancing all the time, as you've put there with the solutions you do, Amir, there are so many options. We just need to see them happen and be allowed to happen.
I totally agree with you, Phil, that the regulations actually all over the world, and I try to touch it in my previous words, that all phenomena of grid being a bottleneck is because the regulators didn't be aware that the grid is a key factor, the third vector, as I called it in my words, and no question that regulators should be much more open and much more assertive and creative in order to push the utilities to go into further steps. May I give you an example we experience in the United States? We have been asked by FERC to take part in the hearing regarding dynamic line rating, which considered as one of the most important parameters in grid utilization. And utilities say, look, it's cost so much money. It cost about $50,000 for 1 mile. It's crazy, and we do not really need it, etc., etc. So we show them that such a solution can cost 1/50 of the numbers they mentioned, and the issue of install such a DLR solution today, modern solution, is not so problematic issue, and the benefits will be produced can be measured by billions of dollars. So within few weeks, within a month, after 2 or 3 years, FERC intend to publish a rule require or force utilities to use DLR. I believe that such a process, 3 years process, could be summed up in 6 months. Why the process is so long? So this is only example, and I totally agree that regulators should be much more open and proactive in even sometimes leading the processes and not waiting just to see technological opportunities to be implemented in the systems. And by the way, Phil, do you think that the emerging of EVs, electrical vehicles, will increase the power or the force to the right direction, meaning regulators will better understand the necessity to deal with electrical vehicles and will enable both producers like you or project developer, etc., to solutions like ours to go more faster and wider.
I think the EVs is a tricky one, and it's complex around it in terms of can you treat an EV as a piece of infrastructure almost to help the grid? I think the question becomes around there is what reliability is there around that at what period of day, and is almost, I feel, those are, I think the problem should be dealt with separately. I think that those are nice to haves around the grid, or having a working assumption that there's going to be an element of fully charged cars sat there connected to the grid, ready to discharge at a point in time, not knowing if that person needs to leave the house to go and do to work or to go and do a job. It is that seems a very complex way of dealing with something that probably is a little bit more simpler from an asset point of view. That's just my opinion. It is almost a battery for a car is for a car. You charge the car, and the car needs to do what the car needs to do. To assume that this battery is now, that we in running a reliable grid somehow need to rely on car batteries to be connected to the network, I think we've got a bit of a problem. I think if that is a business case for a homeowner, that maybe at certain times of day they can make some financial gain, then I'm all for it. I just think where there is expecting that the EV side of to come into some sort of energy long-term net zero solution, I think is probably thinking a little bit too complex around the issue.
I agree with you, and even more than that, I think that the all, including regulators, which we have complained about them, fully understand that extreme weather, electrical vehicles, even geopolitical issues like in Ukraine, etc., affect gas flow. All eventually we can affect the grid, and the grid is so central building block that and from practical point of view, there is no way to have more than one grid in the same area. So it is not a question of competition, like in cellular or so. So the grid should get the right attention from the regulators and business models to enable them to achieve the required challenges. I can say, something positive about regulators, that during the last 5 years, there are some movement, there are some changes, but as usual, it's not enough. And I can say we are talking today about transmission grid. And based on experience in several places in the world, I can definitely say that problems we used to see only in transmission grid nowadays leak into distribution. For example, electrical vehicles sometimes load the distribution line, so dynamic line rating also become applicable for distribution lines, etc., and harmonics, etc. So the limit between transmission and distribution sometimes become blur, and both grids should take care for the same problems in high level of collaboration between, especially if the distribution and transmission work by different owners, different utilities.
I'll ask a question. One question that I've got to ask is what strategies are in place to enhance the resilience of the transmission network against natural disasters and other potential disruptions?
If you'd like me to start, the resiliency is one of the main challenges. Now, there are several strategies. In Europe, for example, France, Germany, and Italy invest about €1 billion a year to bury transmission line as part of the dealing with the extreme weather. Also, in the United States, same solution in some part of the continent, knowing that it's a very, very expensive solution. Another strategy is to monitoring the situation of pylons, towers, to understand movement, understand inclination, which starting, because due to floods and so on, which make the soil unstable. So I would say that there are two main strategies. One, investing a lot of money by burying some of the transmission line, and second is monitor the lines in order to understand weakness parts and take the necessity remedies in advance. I would also say that I heard part of the previous lecture, and the microgrid is also part of the solution. So once you have a problem in one area, another area could not be affected. Phil, I'm sure you have something to add.
It seems that decentralization. Yep, sorry, Phil, I'll let you go.
Yeah, so obviously the decentralization that we've seen obviously has created much more resilience than we've had historically. I think this probably comes back to my point on large C&I businesses and some of the solutions that we do is almost how can these businesses, build big renewables that are powering their facilities, cutting their costs. As Amir said, how cheap renewables are these days. If those projects can be connected directly to businesses behind the meter, it reduces strain on the system, it cuts the costs, and it gives these businesses the resilience to invest. So people are attracted to the UK and other European countries for the resilience of their grid network. If that resilience can be further enhanced by renewables and even more sort of technology to create additional resilience, then that is going to attract more businesses to the UK. It's going to benefit the economy, in a much wider sense than just the net zero story.
One thing we heard earlier was the regulatory framework in the UK is quite favourable to building out more renewables and to developing the transmission network. What I want to ask is, Ofgem has hinted that there could be future competition on the transmission network. What are your thoughts on that, Phil?
Any competition is great. I think the lack of competition is probably what led us to the point where we are now. I think if there was competition for on the sort of transmission network and DNO level, people would have sort of competed to create more capacity to be able to get more people connected to their network. I think because people have DNOs and grid have effectively held a monopoly over their part of the network, that's almost encouraged them not to think outside the box and think, how do we compete against our competitors to make sure more people are connected to our network rather than somebody else's, and we are growing the number of homes and businesses that are connected to our network rather than somebody else's. Again, that competition, if that would have existed, we would have had more grid capacity. We would have had more resilient capacity, which would have had more capabilities for more businesses and homes to be built in certain areas. As much as we as a business are struggling to export our power onto the grid, the other side of it is housing developers, big data centers, and commercial industrial users. They're struggling getting additional power off the grid. So the grid, as the enabler, as Amir puts it, is now, it's stopping us getting to net zero as quickly as we can, but it's also stopping the growth of the UK economy, because businesses and people, they can't get the power they need to do what they want to do in their own businesses. So it's not just about the grid enabling net zero, it's actually about enabling economic growth. So the quicker we get on with thinking of the technological solutions to get more out of the existing system, and then think about how we jump through the planning hurdles, we jump through, try and crush the NIMBYism, which is going to be associated with the new cables and substations. The more we do that, the more the economy is going to benefit. We speak to businesses all the time who are saying, we are trying to get more capacity to be able to double our operations, which will double our employment, it will double our output, it will double the taxes we pay, and they can't do it all because they can't get the grid. We speak to businesses who say, we wanted to do this facility in the UK and we've had to look elsewhere in Europe to do the facility, all because of grid. So we really have to think that this isn't the grid isn't an energy generation problem. It's actually a massive, it's inhibiting our economy probably more than we all realize.
Well, infrastructure is essential to growing the economy, and I want to bring it back to the NIMBY point that you raised there, because it's one that I hear a lot of. Trying to get through local planning is an arduous task. I live in Kent, so we get a lot of solar and energy storage projects that submit planning applications and they go nowhere because they get local opposition, and then local councils decide that it's too much of a risk to their electoral fortunes that they end up denying the projects. What would you like to see change with potentially a new government coming in? What would you like to see change in the planning process for critical infrastructure such as energy infrastructure?
First of all, the point you raised is very true. The NIMBY issue is a great one, and that's why part of the technological efforts should be to increase the capacity of existing lines, and there is interesting possibilities for that. That first of all, the regarding planning, as I know, all over the world, it takes 10 years from starting planning till the real line is in the field, and the government should understand that it is crucial, and to come up with legislation which will open or pave the way for the utilities to shorten the not only all factors involved in that, to shorten the way to have more infrastructure. And just one short sentence regarding the previous issue. If we are talking about competition due to virtual providers, it is not solve the infrastructure problem. On the other hand, we just speaking about NIMBY and plants and so on. I don't see a situation where the another two different utilities will be in the same street, compete each other. So not in the future, in the let's say 10, 15 years future. I don't see it's maybe I'm wrong. It's difficult always. It's difficult to prophesy, especially about the future, but difficult to see.
Yeah, I think on the planning point of view, the first and foremost, there's a responsibility on developers to pick the right projects from the start. We're quite lucky. We have a 94% success rate in secure and planning on all of the projects that we've ever done. That's because we don't like spending money on things that don't get the right result in the end. I think part of the problem has been the historic way that projects have been developed. So first people get a grid connection and then they try and get planning. So people have got a good grid connection and then got a bad site for planning. So that then either gets refused or it takes a long time. So there needs to be some responsibility on developers to put forward the right project. I think with the changes to, with the connection reform in the UK, that is going to steer developers more towards picking the right sites first time. Because now, if you don't secure planning approval, or historically, you didn't have to give your grid connection back. You could sit on it for quite a long time and it clogs up the connection queues. But the way with the connection forms, the way they're proposed, that's going to make people think, or developers think, about the projects that they put forward into planning, knowing that if that project fails, they're going to lose that grid connection and they're going to drop down the connection queue and potentially be left with nothing. So I think from a planning point of view, there needs to be, one is the developer side, put forward better projects, robust projects that are gonna, you're never going to please everybody, but that they are going to tick the boxes that are necessary. Don't go after a fight. I would say the next part is then, well, what happens when you are in planning with your project? There needs to be a better emphasis on the project and the location. Planning officers in general are very well informed. They know exactly what the projects are and they know exactly why the location is chosen. The problem is you can put months and months and months of work in with a planning officer. So the problem is that planning officer has done a lot of work. They then recommend to approval to a planning committee who don't know anything about energy projects. They don't know anything about, they're not trained. Planning committees then comment on wildlife, ecology, location, and the planning department actually has specialists in all of these areas, but then for some reason it's submitted to a committee who aren't specialists in any of these areas. They're elected politicians, and then they have a political view on the project, which for us, there is an element of around energy projects is putting it more into the control of the planning department to make that right decision first time. They have to tick all the boxes. Yeah, they have to go through all of their statutory consultees. It has to be right. This process that we have in the UK of referring it to a planning committee to be able to decide on something where they probably only picked it up 10 minutes before the planning committee, that's not right. So I think, there should be a greater emphasis on and greater weight towards planning managers and the statutory consultees within a planning department to give those. That's going to be really important, not just on the project side, but when it comes to, giving the permission for the great grid upgrade and the new pylons and the new, we can't let the local politicians make emotional decisions on something that technically, that I was at the end of what I was saying.
I was going to agree with you in terms of we need to put things back into the hands of the experts, because even locally there was the project that was planned where all the experts said yes, it's absolutely fine, that it poses no fire risk. And then the local committee decided, no, it poses too much of a fire risk. They're not experts, but
exactly, and that should be allowed. People, we're trying to get to net zero quickly. developers invest a lot of money in projects, and there should be a more, tick box, streamlined system to be able to, the grid is an enabler of net zero. So is planning. It needs to be, there needs to be some improvements there.
As we just wrap up, I have one question from the audience from Elena. As big customers have been applying for capacity they have not been using, but DNOs are required to reserve, then pay for big investments in the network, can you, Phil, suggest a way to deal with that issue?
You have customers who are, they're applying for capacity on the one side, and you have some old antiquated. I think there should be, at the same time as the generators should be pushed down the connection. If I'm understanding the question right, apologies if I'm not. As much as developers are pushed down the queue, there should be, an element of customers are pushed down the queue if they're not using the capacity that they've been used or allocated. So I think there's always, there's multiple sides of the equation which need balancing out as quickly as possible. So yeah, I think from developers need to use or lose their grid connection, and I think large commercial industrial customers should.
Hopefully, Elena, you heard most of that answer. That's all for today.